Hello friends, I am Assistant Professor Milan Patel from Electrical Engineering Department, Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. Today we will discuss chapter number 3 of Elements of Electrical Design. The topic is DC armature winding. So first of all, flow of contents. First of all, we will discuss about definition of the armature, then important definitions related to the armature DC winding, then types of DC armature windings, and last the applications of the armature winding. Now definition of the armature. Armature winding is an electrical machine is that winding which carries the load current. In other words, we can say that it is the winding in which EMF is generated due to the air gap filled flux. So this definition is for motor purpose, DC motor purpose, and this is for DC generator purpose, because this load current is stands for DC motor and generated EMF stands for DC generator. So this yellow portion is called armature because in which the load current will flow or an EMF will induced. That's why it is called armature. Now important terminologies or important definitions. So first of all, conductor. It is defined as the active length of wire in which EMF is induced. So it is active length of wire in which EMF will induce. In this figure, the portion AB and portion CD is active conductor in which EMF will induce. So now overhang. The portion of coil which just provides a connection between the two active conductors and does not take part in energy conversion is called overhang. So we see that AB and CD are the active conductors, and this triangular portion is an overhang which will not take part in energy conversion, whether it is motor or whether it is generator. So this is a overhang. Now turn. The two conductors placed in different slots when connected together forms a turns. So the conductor AB and conductor CD will placed in different slots and connected by overhang, then it is called one turn. So first conductor is called front conductor and the second conductor is called back conductor. Front conductor is denoted by the straight line and back conductor is denoted by the dotted line. Front conductor is also called top conductor and back conductor is also called bottom conductor. So this is a one turn, this is two turn, this is three turn. Now coil. The two active conductors with overhang is constitute one coil. It may be one turn or multi-turn coil. So this two active conductor with overhang is constitute one single turn coil, Then this is a double turn or two turn coil because it consisting two number of coils. This is three turn coil because three turns are there. Now coil pitch. It is a distance between top and bottom coil sides of the coil. It is measured in terms of armature conductors. If the coil pitch is equal to pole pitch, the winding is called full pitch winding, otherwise it is called short pitch winding. So coil pitch is the distance between top and bottom coil sides, and it is measured in terms of conductors. Now simplex and duplex windings. If number of parallel paths between the brushes is twice the number of poles, then it is called simplex lap winding, and if it is twice, then it is called duplex lap winding. So this figure shows simplex lap winding and this is duplex lap winding. The main difference is that this is the number of poles is equal to 2 and number of parallel path across this pole is also 2. That's why it is called simplex. Here number of turns is equal to 2 and the parallel path under the one pole is twice the pole, means 4. 2 into 2 4. That's why it is called duplex winding. Now pole pitch. It is defined as number of armature slots per pole. For an example, if there are 36 conductors and 4 poles, then the pole pitch is, this is the by mistakenly written 16, actually this is 36 divided by 4 is equal to 9, and in figure there are total number of slots is equal to 16. So 16 slot divided by number of poles 1 2 3 and 4, so 16 by 4 is equal to 4. So pole pitch is for this figure is 4, and this is the arrangement of the coil. This is front conductor and this is back conductor. In between 3 number of slots are vacant. Same here, because the pole pitch is 4, that's why the vacant slots are 3. Now front pitch, YF. It is the distance in terms of armature conductors between the second conductor of one coil and the first conductor of the next coil. Or another way, it is the distance between two coil sides that are connected to the same commutator segment. So we can write any of it with. So this is the definition of front pitch. We will see it in figure later. Now back pitch, YB. The distance by which a coil advances on the back of the armature is called as back pitch of the coil. It is measured in terms of armature conductor. Now resultant pitch Y or winding pitch Y. The distance between the beginning of one coil and the beginning of the next coil is called as resultant pitch or winding pitch of the coil. Now commutator pitch YC. The distance between the two commutator segments where the starting and finishing end of coil are connected is called commutator pitch. For lap winding, YC is equal to +1 for progressive winding and YC is equal to -1 for the retrogressive winding. This is a minus. And for wave winding, YC is given by Y by 2, where Y is equal to resultant or winding pitch. Now in this lap winding we will see the front pitch. So we can simply see that this is YF and it is front pitch. This is the distance between two coil sides which are connected on the same commutator segment. So here on commutator segment 2, two conductors are connected, this and this, and the distance between it is called YF front pitch. Now YB. So YB is the distance between the front conductor of the coil and the bottom conductor of the coil. So this is the YB, back pitch. Now the resultant pitch or winding pitch is defined by the distance between two starting conductor of the nearby coils. So this is coil number 1 and this is coil number 2, and this is the coil number 1 starting conductor and this is the coil number 2 starting conductor. So this is the distance between them and it is simply called winding pitch or resultant pitch. Same for the wave winding. So this is the YB, this is the front pitch YF, because they are connected on the same commutator segment. So this is YF, Y, and this is Y, winding pitch, resultant pitch, and this is the commutator pitch because the distance between two starting coil commutators. Same here, distance between two starting conductor commutators. So YC. Here Y is given by YB minus YF. Y is given by YB minus YF, and for wave winding Y is given by YB plus YF. So this is the main difference between them. Now next definition is single layer winding. The winding in which whole slot is occupied by single coil is called single layer winding. So this is a single slot and single coil side or conductor is placed inside it. This is wedge which is used to close the slot, and this is lip from where we can put this coil side. So this is a simple single layer winding. Now double layer winding. From the name we can simply imagine that it has two layers. First one is top layer and second one is bottom layer. Same lip and wedge will wedge and lip is also there. In top layer, top coil side or top conductor is there, and in bottom layer, bottom coil side or bottom conductor is there, and in between top and bottom layer one separator or insulation is there because both the conductors are insulated. So this is the double layer winding. Now types of DC armature windings. Basically armature winding of a DC machine is wound by one of the two methods. First one is lap winding and second one is a wave winding. So basic difference between them is the end connections and commutator connections of the conductor. So lap winding and wave windings are the main types of the DC armature winding. Now lap winding. In lap winding the successive coils overlap each other and it is also called parallel winding. In a simplex lap winding the two ends of coils are connected to the adjacent commutator segments. In lap winding, number of parallel paths is equal to number of poles. So number of parallel paths is depended on the number of poles. That's why it is called parallel winding. So this is the basic diagram, schematic diagram of the lap winding. So simply we can see that it is in lap form. It is in lap form like this. So this is a lap winding. We also discussed that the resultant pitch y is given by yb minus yf for the lap winding. Now again the lap winding and wave winding is divided in progressive and retrogressive windings. So progressive winding is like this, in which the progression of winding is left to right, like this. So winding is progress in right direction from left. Same thing for retrogressive winding. The winding is in opposite direction of the progressive, means right to left. Simple, we can see that this is the in this direction, winding is progression in this direction. So this is the main difference between progressive and retrogressive winding. Now another type of DC armature winding is wave winding. In wave winding, all the coils which carry EMF or current in the same direction are connected in series. So that's why wave winding is called series winding. Another name of it is series winding. Number of parallel paths is equal to 2. Always there are only 2 parallel paths are there. So that's why the number of commutators is also 2 and number of brush is also 2. So the following diagram shows a part of simplex wave winding. So simple, we can see that it is just like a wave. That's why it is called wave winding. If the wave winding is progressive in this direction, means left to right, then it is progressive, and if it is in right to left, then it is retrogressive. Here yc is the commutator pitch yc and given by y by 2. This is the y, and winding pitch y is given by back pitch plus front pitch yb plus yf. So this is the simplex wave winding. Now applications for the lap and wave winding. Lap winding is used for large current motors and generator applications, and wave winding is used for high voltage motors and generators application. Okay, lap winding is used for large current motor because it is a parallel winding. So we know that for more number of parallel paths we can flow more currents, and for more number of series connection we can generate or produce a more voltage. That's why wave winding is used for high voltage motor and generator application. So this is the basic of DC armature winding. I hope you understood it. Thank you.